Hello there, my name is Johnson Makmot, a software engineering student, and I'm going to be taking us through part B of our large vision models from a disease retinal screening in Uganda healthcare. And the target customers are ophthalmologists. The short video demonstration is submitted in the submission link that was provided. Going on, our problem space and purpose, our objectives: high prevalence disease like the diabetic retinopathy, glaucoma and hypertensive retinopathy, and more other eye diseases. So our core problems: limited access to ophthalmologists and special screening equipment. Then explore experiences in mostly patients in rural areas. And why is AI essential? It provides content-based reasoning and decision for certain eye diseases and lowers the retinal scan diagnosis time. So what's measurable impact? Reduce time spent on each patient. So our users, stakeholders, and ecosystem actors, we have primary users who are ophthalmologists and people with eye diseases. Then secondary stakeholders are hospitals, Ministry of Health, etc. Then the ecosystem roles is data suppliers, API consumers, algorithm designers, platform maintainers. Government entities are NITA Uganda, Ministry of ICT, and national guidance. So data sources and value have the RFMID, which is the retinal fundus multi-disease data image in the image dataset. Then a dataset for multi-disease dissection research. The sources are the image, the data are the open dataset from retinal fundus multi-disease. That image dataset. Then the processing pipeline is collection, cleaning, annotation, validation, storage. Then the ethical legal framework is compliance with National Protection Acts and informed consent. The value mechanism is the images used during training provide the backbone for knowledge base. So solution: the LVMs for multi-disease retinal screening in Uganda. What are the methods used? Use the graph clip, use the visual language GNN, seeing graph transformer VIGNN. And what are the models inputs? We have the inputs which are retinal image scans, outputs which are a percentage prediction of images. How does the AI generate our decisions? Analyzes the retinal fundus image with a deep learning model. Then predicts the diagnosis. Diabetic retinopathy, when a confidence level score shows how a certain model is about prediction. So how does it integrate in the user workflow? AI integrates seamlessly into clinical research. Then TF Lite exports, enabling deployment on mobile edge devices. So the system incorporates several responsible AI mechanisms to ensure fairness. Explainability: we have the GradCam visualizations, and bias control: we have the dataset was balanced across demographic and image variations, e.g. age, gender. Then the data privacy: we have all images and anonymized and stored securely following standard data protection policies. So the key metrics and the technical metrics are accuracy, the F1 score, precision of disease detection, latency per image, which is less than 1 second target. And then throughput, images processed per second, up to 99% operational reliability. Error rate, no false positives and negatives, and the target is greater than 80% accuracy, 99 uptime. User-centric metrics, adoption rate: we have percentage of clinicians using the system or greater than 80%. Session duration, efficiency of diagnostic workflow, 90% target. Likelihood to recommend, plus 50 or more. High usability and trust among clinicians. So key metrics and evaluation: ethical metrics, fairness, where there is equal performance across demographics, interoperability. We have the sharp GradCam, bias mitigation, balanced and diverse datasets, and the transparent score with clear explanations of confidence levels. So our business metrics are simply customer acquisition cost, then the lifetime value, the churn rate, which is lower, is equal to better retention, then the revenue growth, which is greater than or equal to 20% yearly. The return on AI investment is positive within 12 to 18 months. So unfair advantage and differentiation: our competitive edge is have a mobile app that works offline. What do you have? Others can easily copy with proprietary datasets, IP partnerships, etc. So what learning or feedback loops strengthen our productive time is a continuous learning mechanism. Each time a clinician validates or corrects a model prediction, the feedback is logged and can be used to retain or refine the AI model. So this leads to ongoing performance improvements. So how does our AI model infrastructure sustain long-term differentiation? That's going to be scalable infrastructure. So this system supports deployment via TF Lite, enabling offline computation in the mobile app, ensuring adaptability to history, hospital networks, mobile screen devices. So channel and distribution, the objective here is the medical personnel has a computer where I upload all the retinal scans. Can attach an external eye-specific camera that accurately captures retinal scan and uploads them directly to the system to get results. So acquisition channels, we have the partnered with Make Club. Delivery channels, we have free web interface. It can be accessed by doctors with a free API endpoint. Collaboration, Make Makere. The rotation tactics, continuous updates, and more model training to ever increasing retinal scans from around the world. The revenue models, we have subscriptions like SaaS, licensing fees, pay-per-use APIs. Then direct revenue models, we have DaaS, which is data as a service, consulting services, ecosystem partnerships. Value-added streams, direct one-time sell-off, basically to governments in countries. So key resources are human resources, where AI engineers, ML, researchers, data scientists, medical personnel, technical infrastructure, having Hugging Face, pipelines, and ML ops. Data infrastructure, data retinal funds multi-disease image dataset. Then organization resources, we have collaborations with Makeup. Then financial resources, seed funding, grants, venture capitalists, and strategic partnerships. Then we have model life cycle activities like data acquisition, labeling, model training, testing, retraining, deployment. Then the product development activities are feature engineering, UX design, API development, testing, and integration. Operational activities, monitoring model drift, maintaining data pipelines, and ensuring uptime. Community governance and compliance. We have conducting AI audits, bias assessments, and aligning regulatory frameworks. Customer focused activities like technical support, community building, user feedback, and loops. Um, so we have technical partners like cloud services, Hugging Face, and Azure. Data partners, universities, NGOs, and bodies, open data repositories. Ethical oversight partners, regulatory agencies, ethics boards, accessibility councils. Distribution partners, telecoms, digital hubs, fintech platforms, and e-learning systems. So data costs, we have annual label for datasets and local collection from various regions, compute infrastructure, cost GPUs, TPUs, cloud storage bandwidth, APIs, human resource, cost salaries for AI engineers, data scientists, product managers, and ACCs, compliance, legal costs, data protection, auditing, certification, and intellectual property protection. Marketing and distribution costs, community outreach, customer acquisition events, promotional materials. So governance model, we have oversight by MICLAB and Dr. Galiwango to meet the intended expectations, fairness and bias auditing, regular model benchmarking and comparisons with other models are carried out. Transparency mechanisms, we have an open model on having first that can be interacted with through an API. So tools, we have Lime, Sharp, GradCam, counterfactuals, legal and ethical frameworks, we have GDPR, PDPA, UNESCO, accountability, all queries and call made to the model or endpoint are logged and stored for reference needed. Scalability framework of microservices. Then continuous learning models updated quarterly when you captured retinal images, scans. Localization currently it only supports English. Financial sustainability, they have the revenue investment, partnership grants, impacts investment. Environmentally, responsibility, we have energy efficient models, architecture, carbon footprinting, resilience, back systems on backup server to prevent data and history loss. The idea is copyrightable because it's an innovation which increases and eases the operations of medical people and the whole industry at large. Custom AI algorithms and model architecture, data processing and pre-processing pipelines. Data distribution, I worked on dataset acquisition and model visualization. Yeah, thank you very much for listening and have a good day.